Okay, so in this video, I'm just gonna be doing kind of a recap of what we've talked about so far in this unit. So the homework assignment is the review all properties of exponents worksheet. So to go along with that, I wanted to kind of talk through all the things that we've done so far in this unit. So I want to talk about the different properties, sort of lay out all the properties that we've learned. So let's do that. So the first one is the multiplication property of exponents, which basically we're saying that if I have something to a power times the same base to a different power, then I can add the exponents. So that works if and only if the bases are the same, right? Along with that, we've talked about if we have two things with the same base that are being divided, right? That's a 3. I don't know if you can tell. It's a 3. Then we're going to subtract the exponents, right? If we have two things with the same base that are being divided, we can subtract the exponents. This is our division property of exponents. So these are the main big ones that we've talked about, the two really big ones. The other one would be if I have something to a power to another power, then I'm multiplying the powers. So 3 times 2 is 6, right? So if I have a power to a power, then I'm multiplying those powers. And along with that, if I have two things in parentheses, then I have to distribute the power to both of those things. So that's going to be a to the third, b to the sixth, right? I have to distribute that power. So these are kind of related, but just a little bit more applications with this. We've also talked a lot about negative exponents. If you have something to a negative exponent, then that becomes a fraction. To the positive exponent, you put it to the bottom of a fraction. So either you can write it like this, or you can write it like this. This is the same thing. If I have a fraction to a negative power, then I'm just going to flip the fraction. So I'm going to take the reciprocal. In other words, I'm going to flip the fraction, and that would be to the positive power. And then I would have to distribute that 2 to the 3 and the 4 in order to simplify this any further. I'm out of space, so I'm going to start erasing things. So if you want to write things down, go ahead and pause the video. If I have, so I want to continue talking about negative exponents because there are a couple more examples with that I think are important. So the other thing, if I have something that is negative in the numerator, then that's going to move it to the denominator. If I have something that's negative in the denominator, that's going to move it to the numerator. So I could rewrite this like this, and then like this. And unless otherwise stated, or unless it's scientific notation, I always want my answer to have positive positive exponents. That's going to be a big deal. So other things that we've talked about, anything to the 0 power is 1. And I mean anything, so I could have x, y squared times 205. But if that's to the 0 power, that's just going to be 1. Anything to the 0 power is 1. And then along with that, if I have 1 to a power, if I have 1 to any power, so I'm just going to write m, because it could be literally anything there. If I have 1 to any power, that's still 1, because 1 times 1 is 1, times 1 is 1, times 1 is 1, right? It doesn't matter how many times I multiply it, I'm still going to have 1. So 1 to any power is 1, and anything to the 0 power is 1. So those are going to be important. The other big sort of concept things that we've talked about are what happens when you have a fractional exponent. So if I have b to the 2/3, for example, remember that that's the same as having a cube root of b squared. That denominator becomes the index, and vice versa. I could write, right, if I wrote that, that's the same thing as b to the 4/5 power. So I can go in either direction with this. So that's another big concept that we have covered in this unit. One more thing that I want to talk about. I kind of mentioned this because I mentioned distributing, but I also want to talk about the fact that it can go the other way. So if I have a to the 3rd and b to the 3rd, I can rewrite that as a times b to the 3rd. So as long as the power is the same, this time the bases are different, so I don't add the exponents because the bases are different. If the power is the same, then I can pull it out of a parenthesis, essentially. So if the power is the same, I could pull it out and just multiply the bases. And if the bases are the same, I add the exponents. So that's kind of that. If I have bases and powers are different, there's nothing I can do with that. That's as simplified as it gets. If they're both different, I can't do anything. If the bases are the same, then I add the exponents. If the bases are different, but the exponents are the same, I can multiply the bases. And that goes the same for division as well. So if I have bases are different, but exponents are the same, then I can divide the bases and then put them to that exponent. Only if the exponents are the same. This is basically just the opposite of distributing, right? Because if I had this in a question, I would just distribute the 3 and I would be here. And if I had this in the question, I would just distribute that 2 and then I would be here. So this is just sort of the opposite of that concept, saying, okay, if the exponents are the same, I can divide the bases. If the exponents are the same, in this case, I can multiply the bases. But again, this is only if the exponents are the same. If the exponents are different, then there's nothing I can do if the bases are different. All right, I think that's all of sort of the big concepts that we've covered. So make sure you're continuing working on Khan Academy, continuing working on the worksheets. And if you have any questions, let me know. Oops.